So, hello everyone. We'll be discussing about loan creditworthiness classification today. Now, as the name suggests, it is a classification problem. So, we have received some data from bank which contains two CSV files. Now, these files are applicant.csv and loan.csv. Now, this applicant.csv is representing the profile of the applicants, that what is their income, what is their marital status, their dependencies, housing, etc. And the other file that we have is about the loan. Now this file contains all the data such as what is the interest rate, what is the duration that it has been taken for, the purpose, etc. Now this file will be using to do all our exploratory data analysis, feature engineering, etc. And we'll be also building a machine learning model on it. So yeah, moving forward, we will go through the procedure that I have followed for this particular project. So here is a high level diagram representing how the workflow of the project goes. First is about the data management, that since we have two CSV files, we'll be needing to merge them together. We'll look how it is done. Next, we have EDA. Now, EDA stands for Exploratory Data Analysis. Now, here what we do is we explore the features that have been provided to us in the CSV files. By features, I mean the columns basically. So, looking at the CSV file, we'll be looking at individual column and looking at how the data is spread, how the data is present, what sort of data is present into it, and etc. Next is feature engineering. Now, feature engineering is something that will be converting data, the column from one form to other, will be transforming it, will be filling up the values, will be deleting some values, and this all process is known as feature engineering. Next, we'll do some feature selection. That feature selection basically means that out of all the given features or all the given columns in our merged data set, we'll be picking up the ones which are like having the most correlation or like having most relevancy towards our output. For example, there is a column that does not mean anything to it, as for example the applicant ID. Now applicant ID doesn't contribute anything to the model's learning because it is just a unique identifier of the record. So such columns will be not using for our machine learning model creation. And that is now this process of picking up a particular mm, feature and not picking up a particular feature is called as feature selection. Next we'll be moving towards model building. Now once you're ready with your set of features, we'll be going for model building. Now what does model mean is basically we'll be passing our data to various algorithms, figure out which one is the best, and then after receiving after generating its accuracy and then testing it on various metrics, we'll be taking the judgment whether we have to continue with it or not. But even after that, if your model is giving very less accuracy in some cases that you were expecting it should be higher, so in that cases you can go for an advanced step called explainable AI. We'll be discussing about it further. Now this explainable AI basically represents how the features are contributing to it, what change in a particular feature might result in better accuracy, and it provides a lot of insights on how ideal the data should be, that is coming in, and how the model is trying to adopt to the data that has been provided. So this is a high level uh, workflow of what uh, I have been doing on this project. So we'll just hop onto the code. We'll go to the code and mm, iterate it once. Now you can see this is the first step of data management. As we saw in the workflow, we are importing both the applicant and loan CSV files. We are, as you can see, they have the shape of 1000 records and 15 columns for the first applicant's CSV, and then it has 1000 records and 13 columns for the loan file. Now we'll be merging them. So here you can see the rows. We have we have rows equal to 1000 and columns equals to 15 plus 13 minus 1, because applicant ID is repeated twice. So we'll be subtracting 1 from it. Now this figures out to be 27 columns. So as you can see, we'll be having in the final merge data set, we'll be having 1000, the shape of 1000 comma 27. Now this 1000 represents records and 27 represents the column values. Now this is how the data looks like. Okay, so we have this applicant ID, then we have age, we have gender, we have marital status, number of dependents, etc. Now moving forward, we'll have to do a lot of analysis of this data, that how the data is spread, how the what sort of data is present, what sort of data we can use for our final classification. Now, as you can see, the last column that we'll be having in this is high risk applicant. Now, this is a Boolean value. It is represented in 0 and 1. Now, what this basically means is that whether a particular applicant is high risk or not. So basically 0 represents false and 1 represents true. For example, for the first ID, it is represented that the high risk applicant value is 0 for him, meaning that he is not a high risk applicant. Similarly, we'll be exploring all other features as well and understanding how they relate to our problem statement. So yeah, now there is one more concept of pandas profiling report. Usually it is a good practice to have uh, a report of your data set. Now this is an automated library that does reporting for you. So it basically creates a report for you looking at the database. Now we'll just look at the report that it has created. I have already run this cell, and since we don't want to run it again and again, I have commented it out. So yeah, now this is how the pandas profiling report looks like. So here it figures out a lot of statistics about the data. So it is like it basically represents how many missing cells are there, how many duplicate rows are there. Next up, now it does the same thing on all the columns that are present. So it is calling the columns as variables, which is, and we can call them variables, we can call them features, we can call them inputs, we can call them a lot of things. So this is the applicant ID, and here he's explaining how applicant ID is being sprayed. So as we know, it is just a unique identifier, so it won't have like a proper distribution or something. But you can see that the maximum and minimum values are there, although it doesn't make sense because they are only for unique identification. A good thing is that there are no missing values, so it means the data is relevant. Now next up we have this age. Now age is something that is very important to us, okay, because like age is, as you can see, in general terms, age is something that matters when it comes to repaying of a loan. So just imagine someone taking a loan at the age of 60 might not be able to repay it, and someone who is comparatively younger might be in a better position to repay it. So like this parameter comes out to be more useful. We'll discuss about this, how do we get statistically understand how do these parameters affect and all. So this is its rough distribution. All right, and now it is telling about a lot of values, like what is the minimum, what is the maximum, how many zeros it has, how it is grade, its mean median mode, and we, if you toggle details, you'll get a lot of more data as well, skewness and everything else. So this is what you can do in order to get a quicker and very faster idea of the data set. Now we'll be moving forward and looking at some important aspects. So we have moved to the second part of our data set, that is exploratory data analysis and feature engineering. So here we are doing a lot of analysis. So like we won't be going line by line because it will consume a lot of time, so we'll just go on to hop on to the important things. Now this is an important cell. It represents how much data is present, data.info. Now it prints all the columns along with their non-null values. So like as you know, there are 1,000 records, in our data. Now you can see out of those 1,000 records, this column telephone has only 404 records. That is, the other remaining data is null. So null, or what we can say, it is missing, so the data is not present there. Now we'll be having to think of some method that will be required to dealing with this telephone column. Yep, so moving up ahead, we have done a lot of other pre-processing onto it. So we have sorted out the columns which have the uh, we have sorted the columns based upon the values that they contain, whether it is an object type, whether it is uh, other type like float, int, str, and others. Now this is something that we are doing. Now we are currently in the exploring the data phase. Now exploring the data is one of the most important and most what do you say, most time consuming phase, if you don't consider the data collection part. So now coming here, you will be seeing the correlations. Now this is a correlation plot. So basically what it says is that for primary applicant age in years, how much it is related to the applicant ID. So applicant ID. So it suggests that applicant ID is like minus 0.0064. Now minus represents that it, like for every increase in applicant's age, the applicant ID reduces. Now it doesn't make sense because applicant ID is not something that is important to us. So we'll quickly come at a value which is very higher, and now you can see what this value represents. So it says for principal loan amount. So the higher the prince, now since this value is positive, we'll say that the higher the amount of this column is, the higher will be the amount of this column. So as you can see here, it is principal loan amount. Yeah. So we'll be having this principal loan amount. Now the higher the principal loan amount, the higher will be the month's loan taken for. So the higher the principal, the higher your duration gets. Now this is how it says. Now this high. Now as you can see, even in a generic term, the more loan we take, the more months we need to repay it for. So this is something that is related. And now this is a way to understand how this data is correlated. So this is a matrix that correlation. Next up, moving ahead, we have some insights listed for from correlation. You can go through this. Next up, we are handling missing values. Now the first step is like we saw that above we listed all the values which all the columns and their missing values. So that is one method. The other method is to plot the same values and look out to uh, how many values are missing. So as you can see, this plot represents these yellow lines represent that that particular data at that point is missing. So as you can see, this column, that other EMI plans, is having most number of missing values, followed by these columns. Now this column is, I'll just read it. Balance in existing bank account. Okay, so balance in existing bank account is null. I don't know why don't bank have this data, but anyways, we don't have it. Yeah, so this is how we will be handling them. Moving forward will be like, now when you're handling missing data, there are like a variety of ways of deciding what exactly you have to do with the data. For example, now here I have listed all the columns along with the number of missing values that they have. The other EMI plans, as we saw, it has 814 missing values. Now that is around 80% of the data is missing, and in this case the best way is to drop the entire column, because generally we won't be wanting to drop any column because we are getting short on data. But if we have a column that has more than 75 or 80% of missing values, it is simply no use because it will waste more time than adding more value. So we drop such data. We'll be doing the very same thing with the balance in existing bank account value, because it contains around 66% missing data. And like for data where we we have less number of missing values, uh, okay, less number of missing values, we can either delete the entire record of that, or what we can do is we can impute those values. Now imputation is some concept in data science or data engineering which saves you from deleting the entire record just because you don't have a value for one column. We'll be discussing about it in later phases. Yeah, so moving up will be, we have done a lot of exploratory data analysis onto it. You can go through this file anytime. Okay, next is, now the next step in our data is feature selection. So feature selection is something that is very important. So before knowing how feature selection is useful, we'll be wanting to do some, now this exploratory data analysis have already put us in a position where we are able to understand how well the data is present, how well the data is spread, how well the data is present. And now once you go to the feature selection phase, you are in a position where you can uh, judge whether these columns are necessary or not. After that, there are also a lot of machine learning methods which help you in doing feature selection process. I'll be sharing you a note after our session that how feature selection is done and how it is important. Next up, we have this model building phase. So I'll just quickly go to the file where we have everything ready and run. All right, so here we are looking for outliers. Look, we have already filled the missing values. So we'll be just looking at how these are some feature transformations that we have done. Now we'll be moving forward about the advanced EDA part. Now looking at this advanced EDA, we'll be drawing some correlation plots where we'll be looking at every feature and its distribution. And then if it is not normally distributed, we'll be trying to make it normally distributed. And then there are a lot of parameters that we'll be working. Now the feature engineering part also contains of one special thing, that is to create your own columns. Yes, you can create your own columns. For example, there are columns like height and weight of a person. So you can eliminate this height and weight columns because you'll be having two columns. Now you can club these two columns by introducing one more feature called as BMI. Now this BMI is something that takes care of both height and weight, so you can add that column there and then eliminate those two columns. Now you might be thinking about why don't we keep both of them instead of what is the need of creating that other third column? We can simply put this. So there is a concept called as curse of dimensionality. That is, the more number of columns you keep adding, after a certain point they become so confusing for the model to learn from. So it is a good idea to, wherever you can, minimize the number of columns to do. Another example for the same case is, suppose you have height and width of a plot. So rather than putting two different columns of height and width, we can simply introduce one column of area, which is the product of both of them, and the area basically represents both these columns in a simpler way. So this is what we have done. Next up, I'll just skip all this part and just move to the model building phase, since we are running out of time. So this is where we have built models. Actually, I have built a lot of models, but now this is something called, there is a lazy predictor which predicts a lot of which predicts its output and gives you an accuracy on by training your data on a lot of models. So this is the output of it, but you can do it on your own as well. So I have trained so in this model building phase, as you can see, I have trained two models. First is random forest classifier and second is logistic regression. Now random forests are usually very good at classification, so it's always my first priority while building a classification machine learning algorithm. Moving forward, we are printing the precision, recall, FN score, and support for them. Now we'll discuss about these things in detail sometime later. Now this is the accuracy that it has shown on test data, that is 61%, which is not really very good, but it is good for a starter point. Next up, we have this classification. We have this confusion matrix. I'm sorry. So we have this confusion matrix. These confusion matrix basically represents precision, recall, accuracy, and everything in a intuitive manner. We'll be discussing what these values mean and everything in some time later. Next will be, we have this logistic regression classifier. Now this logistic regression classifier, as you can see, it only has a probability, it only has an accuracy of 0.599. So we can always hypertune these things and we can do more insightful tasks ahead. Yeah, now there is something called as hyperparameter tuning. Now hyperparameter is tuning when you are confident that an algorithm is not working really well, and then you are also confident that by tuning some hyperparameters, that is, every model has some variables which need to be configured while training data, and these the ideal values of these parameters change based on your data, so the data scientist has to take the call to change these values based upon it. That is what we call as hyperparameter tuning. For example, if we consider about logistic regression, there are two hyperparameters like L1 and L2, and some other parameters as well. In deep learning, if you see, there are epochs, there is batch size, there is uh, there are the learning rate, and there are a lot of other hyperparameters that we need to tune. So for here, we are using some methods to tune this hyperparameters. This entropy and Guinea are like, these are some hyperparameters for the random forest classifier. We'll be doing hyperparameter tuning on only the random forest classifier, since it is it is a better performing model as compared to logistic regression. So we have performed this hyperparameter tuning here. We'll go through the process sometime later, and we can see that as compared to the previous one, we have, like, you can see this precision here. Now this, like, the value in the upper right corner is 19. Our main aim is to reduce this value as much as possible, and it has been reduced from, if you go up from 28, as you can see in this random forest classifier, the value was 28 and it has been reduced to 19. So we have done something good in our hyperparameter tuning, so that we have reduced this value. Next up, we sorry, I showed you the logistic regression. It is same. It is the same for a better random forest classifier. Now we have this precision and recall values. Now precision and recall values, they are representing the same thing, that how precision and recall are changing based upon the two regression random forest models that we have used. Next is this explainable AI part. Now this part is something advanced, and that is like popularized these days. So we have this logistic regression model, and then we'll be applying explainable AI. Now what does this explainable AI does is that how are these features contributing to the model's learning. This is something that uh, it predicts using a concept called as sharp values. We'll be going into its detail later. So this is what it has predicted. So now what these values mean is that the interest paid is the most promising factor or the most contributing factor that is helping the model to learn more. Next up is marital status. Next up is loan history. Then we have average employed years, and then it continues. Now you can see the employment status is not really helping the model to learn much, although it should. Okay, so that is what our model is having the problem. Logically, my employment status should have some good impact on the model, but it isn't having. So that's what our common insight for this is. Next up, we have this summary plot. It represents, now this represents the basically density of how much a particular feature is been useful in it and all. Next is we'll be having the sharp values for hyper tuned random forest classifier. So if you remember that 28 values, 28 wrong classifications were moved down to 19, and now for that better the model that was performing better, that was having less number of misclassifications, we have used it to move ahead, and we are plotting some insights out of it, and then we can always improve the model ahead. So this is what all I have done in this project. I hope you like it, and I have also shared the Google Colab link of the project with you, so you can always visit the link and then try out the project. Yeah, all right, so thank you so much.